Here goes nothing. Well, hello, my little babies. From the 403 to the HAZ. That's like the best I've done it. Woohoo! I am pretty cool. My mama thinks I'm great. Hey guys, we're talking about logarithms. And so far we've kind of been introduced to them and just understanding how they work and how the logarithmic form relates to the exponential form. Because a logarithm is just the inverse of an exponential function. We've talked about that. Then we did some function transformations with our transformations of A, B, H, and K. And now we're going to talk about the laws. Math, all about the laws. So here is our baseline logarithmic function. Y is equal to log base c of x. And we got this from our exponential function, y is equal to c to an x, c to the x. And what we did is we took the inverse of that, which became, all we do when we're taking the inverse of a function is we replace x and y. So x is equal to c to the y. I've replaced x with y with x. Okay, so actually, this and this are exactly the same, but we like y equals form. And solving for y here requires a logarithm. So this and this are the same thing, just in different formats. Okay? And knowing that allowed us to start kind of playing around and solving logarithms. X is equal to c to the y. So these two are the same thing, okay? So now what we're going to do is we're going to start talking about the laws of logarithms, because that's going to help us to simplify more complex expressions involving logarithms. Quite straightforward once we know the laws. So here are the laws. No further ado. No further ado. The laws. I love laws. I'm the law. Okay. The first one is called the log of 1. So the first two are just kind of like really straightforward, really simple. Anytime you see the log with any base c of 1, the log of, with any base here, the log of 1 is always going to be equal to 0. Any log of 1 is equal to 0. Because if we go from here to this format, that means that 1 is equal to c to the 0. Right? So c to the 0 is always going to be 1. So basically this is just showing us that. Because 1 is x, c is my base, so any number to the 0 is equal to 1. So this is where we get this law from. Hopefully that kind of made sense. If it doesn't, all you need to know is log of 1 equals to 0. Sometimes in math you just have to accept the law, okay? The law's bigger than us. You just have to accept it and roll with it. And then once you do that, man, math is easy. When you stop overthinking it, when you just accept it. The other super basic law that's just going to help us clean up a lot is knowing that the log, when my base and my x are the same here, it's always going to be equal to 1. And if we were to go from here to here, so if we were converting from our log format to our inverse format, these are both the same, I could write that c is equal to c to the 1. And I know that any number to the power of 1 is just equal to that same number. So this is just another way of writing that, using our logarithm. So when my base and whatever I'm taking the logarithm of are the same, it's equal to 1. Two quick and dirty, helpful laws. Oh, I thought my laptop. Okay, now let's get into the nitty gritty. Okay, there's 3. I'm going to do the 3 main laws. There's an extra one, but that's on the website anyway. So the first important law is the law of products. Okay? I'm going to call this number 3. And the law of logarithmic products tells me that the log of some base, any base, of two numbers, a times b, so just any two numbers, I can rewrite that as log base c of a plus log base c of b, okay? So if I have two logs that are being added together and they have the same base, I can rewrite it as that base and then those two numbers multiplied, or vice versa, okay? That's the law of products. And just an example of that one, if I had, let's say I had log of 2 plus log 3. Now remember, I didn't put a base here, so we assume it's 10. We assume it's 10. So I could rewrite this as log 2 times 3, or if I wanted to show that base, log base 10 of 6, 2 times 3, okay? That's what I can do there. Okay, that's the law of products. The next law is the law of quotients. So these are going to kind of look familiar to the exponent laws. Oops, you know what? I'm going to use a different cooler. Because we like coolers. Quotient, the quotient law. Okay, these are very similar to our exponent laws, but they just apply to logarithms. So if I have log base c of a divided by b, that is the same as log base c of a, whatever's on top, minus my denominator, log the same base c of b. Now c can be any base. Okay, we see that, we can rewrite this as that. So if I had log base 6 of 8 minus log base 6 of 2, I could, because they have the same base, 6, I can rewrite that as log base 6 of 8 divided by 2, or I could write that as log base 6 of 4. And then if I wanted to solve what this is, I'm in this format, so I know that 4 is equal to 6 to the sum power y, and that would get really ugly really fast, so I'm not even going to try to solve that. Okay, that's the quotient law. And then the final law that we need to use for our textbook problems, I'm going to do an Orhanyo, and that is called, and you can see I'm learning on the fly here. Ooh, it's the law of powers. Ooh, okay, powers. Powers. Number 5. And this law tells us that if I have the log of some base of some number to the power of n, so a to the power of n, log base c, I can rewrite that as just, the n is going to come in the front, as n log base c of a. Okay? That's it. So if I had log base 10 of 2 squared, I could rewrite that as 2 times log base 10 of 2. Okay, those are the laws. Now let's use them. Let's use them to solve some problems. Okay, so what if they gave us, they said, okay, log base 5 of xy over z. Okay? And they said, we want this expressed as individual logs of x, y, and z. So how would you do that? Well, first we have to figure out which laws we're going to have to use here. We have two numbers being multiplied together, so we've got products, but then we also have a division here. And we don't have any power, so we're probably going to be playing with these two here. and it doesn't really matter what order I go in. So I'm going to apply, well, both laws in one go. So, well, first I'm going to do this one. So I can rewrite this. I'm going to first do the quotient law. And I'm going to just treat this as one thing for now. So this becomes log base 5 of xy minus whatever's on the bottom, minus log base 5 of z. Okay, but I still have these two here, and they want it individualized. So now I can deal with this one. And this, I'll use this, it's fairly straightforward. So this becomes log base 5 of x plus log base 5 of y minus whatever was left here, because all I was doing was treating this. Minus log base 5 of z. And now I have rewritten this as individual logarithms of x, y, and z. Okay? That was that. Let's do another one. Let's do another one. Just get crazy up in this mofo. Okay, so that's that. We just split it up. So, this is my first time dealing with this stuff, so I get nervous. But we're figuring it out, okay? I've done this before, but I have never taught it, and it's been a long time since I've played around with logarithms. Let's try log of x cubed over y square root of z. Holy crow. That is all I can say here. Now, we have powers now, right? This I can rewrite as a power. And actually, that's what I'm going to do the first thing. I don't want any square roots. I just want exponents because square roots don't really belong here. So this can be rewritten as y to the 1, z to the 1/2. Okay. Now I've got products here, and I've got quotient here, and I've got powers. Now I'm going to deal with the powers at the end, but first thing I'm going to do is I'm going to turn this into, so it's log, there's no base, so we just assume 10. So it's just a log base 10, but I'm not going to write the base because they didn't. So I can do this as log of x cubed minus whatever was on the bottom, log of y z to the 1/2. Okay. I'm going to get back to this because we'll apply the power laws at the end. Because we can already see that if we apply this log power here, we're going to get something. But let's deal with this now, okay? Let's separate this. So I have log of x cubed minus, I'm going to open a bracket, log of y z to the 1/2. And I'm going to apply the product rule on that. So this becomes log x cubed minus log of y plus log of z to the 1/2. Okay. Now I can apply my exponent laws. I hope you can see this. I am going to bring this, I'm sorry guys, I'm going to bring this up here just so we can see it better. So I have log of x cubed. If I apply the power law, I'm going to pull that 3 in the front. So that becomes 3 log of x minus log y. There's nothing I need to do there. Minus log y minus log z to the 1/2. N, in this case, is 1/2. So minus, and I'm going to pull that 1/2 out front, 1/2 log z. And then that is my final answer in individual logs. Okay? Fairly straightforward if we just follow the rules. Now, there's one final actual law I'm going to put up here. Okay? And it's called the law of reciprocals. I ignored it at first, but you know what? I just can't deny it. I just can't deny the connection I feel with this law. It's undeniable. So we've got our 5 laws here, and then the reciprocal law, which is something that's going to help us out. And we'll do a problem that's going to use it in just a moment. The reciprocal law, number 6, tells us, what does it tell us? The log of some base c of 1 over a number is the same as negative log of some base c of that number down there. Okay? Good law to know. So let's do a problem where we have to use that law now. So I have log of base 6, 1 over x squared. I might put that in brackets there. Okay, so log base 6 of 1 over x squared. I've got 1 over that. So I can rewrite this using this law as negative log base 6, whatever's in my denominator, x squared. But I don't like exponents in my log, so what am I going to do? I'm going to apply the powers law, and then I can rewrite this as negative 2 log base 6 of x. Okay? There we go. Make sure I did that right. Negative 2 log base 6 of x. Okay. So this is now when we are separating logarithms into individual. What if we go the opposite direction now? Ooh, I should keep, where am I going to put this? I'm going to put my reciprocal law up here. I am all over the map today. Reciprocal. Which tells me that, let me see if I can do it from memory. Log of some base 1 over a can be rewritten as negative log some base of that number. Okay, there we go. We got all our laws up there. So we've been going one direction. Let's go in another direction. So, what if they gave us, I'll do one here. Okay. Log base 6 of 8 plus log base 6 9 minus log base 6 2. Okay. And they want just this to be simplified. Okay, they want it simplified into an expression. I am adding and I'm subtracting, adding and subtracting. So clearly I'm using my product and my quotient laws. So I don't know how BEDMAS works here, but I'm pretty sure we can just do whatever we want. So what I'm going to do is I'm going to combine these. I can either combine these two, or I can combine these two. I'm going to start with these two here. Okay? So using the product law, I can rewrite that as log base 6 of 8 times 9. Great. Minus log base 6 of 2. 8 times 9 is log base 6 of 72 minus log base 6 of 2. Now I can use my quotient law, and I can rewrite this as log base 6 of 72 divided by 2, which is 72 divided by 2 is 36. Log base 6 of 36. Okay? That's simplified, but guess what? I can actually solve this because I know that I can rewrite a logarithm. I've erased it here, but this is interchangeable. This is another way of writing x is equal to c to the y. So if I do that, 36, if I use this, so I get 36 is equal to 6 to the y. And then if I use my exponent, what I know about simplifying exponents or solving for exponents, 36 is the same as 6 squared. Now they both have the same base, and when they have the same base, c to the x is equal to c to the y, x is equal to y. Okay? So 2 is equal to y. Y is equal to 2. Therefore, this whole thing simplifies into 2. I'm learning here too, so let's do a couple more examples. Let's see here, I'm learning. Okay, here we go. We've got log base 7, 7 root 7. Holy crap. So we have 7 to the power of 1 times 7 to the power of 1/2. So I don't like radicals, so I'm going to go ahead and rewrite this as log base 7, 7 to the 1 times 7 to the 1/2. Okay, so this is the same thing, I've just written it like that. Now I have a product. Okay? And guess what? I'm probably going to have to use these here too. But let's use a product law to separate this. So I can rewrite this as log base 7 of 7 to the 1, doesn't need to be there, plus log base 7, 7 to the 1/2. This is basically good to go. And if I look here, when my number and my base are the same, it's 1. So I can rewrite this as 1. And this, I'm going to use my power law to bring that 1/2 down, and then log base 7 of 7, which again, this is the same as 1. So this becomes 1 plus 1/2 times 1, or 1 plus 1/2, which is 2 over 2 plus 1 over 2, 3/2. This simplifies down to 3/2. Okay? And I think that's all I'm going to do for now. That's enough to get you guys going. And we'll do some more practice problems. I'll do some more difficult ones once I get my head wrapped around stuff. But this is enough to kind of get you going in the textbook on problems. Probably not all the way, but you know what? Surprise yourself. Okay.